Here we have to integrate e raised to x into 1 plus x log x upon x. This e raised to x within the multiplication of whole function suggests that we have to use integration of e raised to x fx plus f dash x. Now, to get fx plus f dash x format, let's give individual denominator. So we will get 1 by x plus, in second term xx will cancel out and log x will be remaining term. Now here we get f dash x plus fx form, where log x is your fx and 1 by x is your f dash x. Whole bracket is within the multiplication of e raised to x. Now as we know, to integrate this form, we just have to ignore f dash x and your integration is done. So your answer is e raised to x fx, or we can say e raised to x log x plus c, which is given in option A. Ta-da! Here we have to integrate double differentiation of tan inverse x. As we know, differentiation and integration are inverse function of each other. So we can say integration will reduce one order of differentiation. That means we just have to differentiate tan inverse x only one time plus c. As we know, differentiation of tan inverse x is 1 upon 1 plus x square plus c, which is given in option A. Ta-da! लाओ कि नहीं? इंटीग्रेशन અને ડિફરન્શિએશન એકબીજાના ઇન્વર્સ ફંક્શન નહીં. આપણે આવું નહીં કરતા કે sin ઇન્વર્સ ઓફ sin x હોય તો આપણે x જ નહીં લખી નાખતા. એવું એક વખત ઇન્ટિગ્રેશન આ બેઝિકલી આવું છે, બરોબર? તો ઇન્ટિગ્રેશન અને ડિફરન્શિએશન ઇન્વર્સ ફંક્શન છે એટલે d by dx of tan inverse x આવી જાય પ્લસ c. પડી ખબર? હજુ ડેફિનેટ ઇન્ટિગ્રલ છે એટલે આટલું સિમ્પલી થઈ ગયું. ઇનડેફિનેટ હોત ને તો એક બીજો રૂલ છે જે હું તમને નેક્સ્ટ લેક્ચરમાં શીખવાડીશ. ચલો બીજો એક સિમ્પલ સમ કોણ કરશે? રાક્ષી ચાન્સ મારે. Here we have to integrate x minus 1 upon x plus 1 the whole cube dot e raised to x. Here this e raised to x within the multiplication of whole function is suggests that we have to use integration of e raised to x fx plus f dash x form. Now to get fx plus f dash x, we have to separate our numerator. Let's try to get x plus 1 in the numerator. We have x, we just need plus 1. So let's add and remove plus 1. Now if we give individual denominator, considering first term as x plus 1, we will get x plus 1 upon x plus 1 the whole cube, and this minus 1 will become minus 2 whole divided by x plus 1 the whole cube into e raised to x. Now let's simplify. This x plus 1 upon x plus 1 whole cube will become 1 upon x plus 1 the whole square plus minus 2 upon x plus 1 the whole cube will be remain as it is. So we get fx plus f dash x form if we consider 1 upon x plus 1 the whole square as a fx. So let's write down fx is equal to x plus 1 whole raised to minus 2. Then its differentiation must be minus 2 x plus 1 whole raised to minus 3, or we can say minus 2 upon x plus 1 the whole cube, which we already have within the summation of fx. So we get fx plus f dash x form within the multiplication of e raised to x, and its integration is simply done by neglecting f dash x. So here we'll get 1 upon x plus 1 the whole square into e raised to x plus c as your final answer, which is given in option B. Ta-da! Here we have to integrate 1 upon cos x minus sin x. We need answer in terms of log mod 10 x by 2 plus something. So we will try to get sec x, and for that we need to get cos in denominator. Let's multiply and divide by root 2 in the denominator. So 1 by root 2 will be as it is, and in denominator we will get cos x into this 1 upon root 2 can be rewritten as cos pi by 4 minus, in second term, sin x will be as it is, and 1 by root 2 can be rewritten as sin pi by 4. So here we get cos alpha cos beta minus sin alpha sin beta, which can be easily simplified as cos alpha plus beta. So in denominator we will get cos x plus pi by 4 dot dx, or we can say we just have to integrate sec x plus pi by 4. So we are ready to integrate sec theta, which is log mod 10 half the angle, or we can say x by 2 plus pi by 8 plus c, which is given in option. Tada! Here we have to integrate 1 upon sine 2x from pi by 6 to pi by 4, or we can say this 1 by sine 2x can be rewritten as cosec 2x. Integration of cosec x is log mod cosec x minus cot x. So integration will be log mod cosec 2x minus cot 2x. Limit is from pi by 6 to pi by 4 upon coefficient of x, which is 2. Now to get the final answer, we just have to substitute the limit. From upper limit we will get log mod cosec 2 times pi by 4, or we can say pi by 2, minus cot pi by 2, minus from lower limit we will get log mod cosec pi by 3 minus cot pi by 3. So here your 1 by 2 will be remain as it is. Log cosec pi by 2 is simply 1, and cot pi by 2 is 0, minus log your cosec pi by 3 is 2 by root 3, and cot pi by 3 is 1 by root 3. Now here your 1 by 2 will be as it is. This log 1 will become 0, minus we will get log of 2 minus 1, or we can say 1 upon root 3. This negative sign will go within the power of 1 by root t, and we will get 1 by 2 log root 3. So 1 by 2 log root 3 is your final answer. Tada! Here we have to integrate sec x plus tan x the whole square, which is in the form of whole square of a plus b. So it can be expanded as a square plus 2 times ab plus b square. So here we'll get sec square x plus 2 times sec x tan x plus tan square x. Now first two terms can be easily integrated, but to integrate tan square x we have to convert into sec square x minus 1. So let's write down our first two terms as it is. Now this sec square x plus sec square x will become 2 times sec square x. So we are ready to integrate. 2 will as it is. Integration of sec square x will be tan x plus 2 as it is. Integration of sec x tan x will be sec x. minus integration of 1 will be x plus c. We can take 2 common, so we will get 10x plus sec x minus x plus c as your final answer, which is given in option A. Tada! Here we have to integrate x raised to 51 into tan inverse x plus cot inverse x. But here, as we know, tan inverse x plus cot inverse x is simply pi by 2, which is purely constant term. So in integration, we don't have to worry about this pi by 2. We just have to integrate x raised to 51, which will be x raised to 52 upon 52 plus c. But our answer is not within the options. So let's replace the original value of pi by 2, which is tan inverse x plus cot inverse x, and your x raised to 52 upon 52 plus c will be remain as it is. So now we get our final answer, which is given in option A. Tada! In this question, we have to integrate x minus 1 upon x plus 2 the whole square. We have two polynomials. The order of first polynomial is 1 and order of second polynomial is also 1. So we can use long division, or we will try to get denominator in terms of numerator, or we can assume non-expandable term as x plus 2 is equal to t. In this question, I will select second option. Let's try to get x plus 2 within the numerator, and for that we have to add and remove 2. Now for further simplification, let's separate the terms. Let's consider x plus 2 as a one term and give individual denominator, and your second term is minus 1 minus 2 will become minus 3 upon x plus 2 the whole square. So in further simplification, we will get 1 upon x plus 2 in first term and minus 3 x plus 2 whole raised to minus 2 in second term. So we are ready for integration. Integration of 1 upon x plus 2 is log mod x plus 2 minus 3 x plus 2 raised to minus 1 upon minus 1 plus c. So tada! This is your final answer. Here we have to integrate 1 upon sin x plus root 3 cos x. Let's multiply and divide by 2 in denominator. So here we'll get 1 by 2 and root 3 by 2 cos x. If we try to set cos in the denominator, we have to replace this 1 by 2 by sin pi by 6 plus this root 3 by 2 can be rewritten as cos pi by 6. Your cos x will be as it is dot dx. So we will get sin alpha sin beta plus cos beta cos alpha form, which is equal to cos of alpha minus beta. So in denominator we will get cos of alpha, or we can say x, minus beta, or we can say pi by 6 dot dx. Now this 1 upon cos can be rewritten as sec x minus pi by 6, and integration of sec is nothing but log mod tan half the angle, or we can say x by 2 minus pi by 12 plus pi by 4 plus c. So you will get 1 by 2 log of tan x by 2, and this minus pi by 12 plus pi by 4 will become your plus pi by 6 plus c. So tada! This is your final answer, which is given in option B. Here we have to integrate log x upon x under root of 1 plus log x. Here we have the function of log x and its differentiation is available within the multiplication of dx, which suggests that we have to assume log x equal to t, but 1 plus log x is your inner function. So let's assume 1 plus log x is equal to t. log x મને શું તો પાછો denominator simplify કરવો પડશે, એના કરતા આના જ લઈ લઈએ તો સારું. Now if we differentiate both the side, differentiation of 1 will be 0, differentiation of log x will be 1 by x dot dx will become your dt. Now we are ready to modify our integration. This log x will be your t minus 1 upon under root of 1 plus log x will become your t, and this 1 upon x dot dx will become your dt. So to integrate term, let's give individual denominator. In first term we will get t upon root t, or we can say t is to 1 by 2, and in second term we will get 1 upon root t, or we can say t is to minus 1 by 2. So we are ready for integration. Integration of t raised to 1 by 2 will be t raised to 3 by 2 upon 3 by 2 minus integration of t raised to minus 1 by 2 will be t raised to 1 by 2 upon 1 by 2 plus c. Now here in first term, if we substitute the value of t, we will get 1 plus log x whole raised to 3 by 2 minus in second term we have t raised to 1 by 2, or we can say 1 plus log x raised to 1 by 2 into 2 plus c. Now if we take 2 by 3, 1 plus log x whole raised to 1 by 2 common, we will get 1 plus log x minus 3 plus c, or we can say this 1 minus 3 is simply log x minus 2, which is given in option B. Ta-da!